Welcome to the channel. Before we begin, I'd like to ask you to support the project by subscribing to the Telegram and YouTube channels. Click the bell to receive all notifications. Like the video if you found it interesting and leave comments. You can also follow the links in the video description to articles and read them. This will greatly help the channel.
All right, let's talk about a huge leap forward in robotics. And, it's coming from a place you might not expect, a smartphone company, of all things. What they've managed to build could fundamentally change how machines see, think, and interact with our world. So let's just dive right in. For decades, this has been the central challenge. It's the big one. We've all seen those robots that can play chess, but then they trip over a rug, or the ones that can do a backflip but can't figure out how to open a simple door. Getting the brain and the brawn to actually work together in harmony, that's been the holy grail. And that, right there, is the big news. A brand new model from Xiaomi has basically cracked this problem. And they did it with a surprisingly elegant solution, creating robots that don't just act, but, well, it feels like they understand. So let me introduce you to this Xiaomi Robotics Zero model. This thing is a 4.7 billion parameter powerhouse, and it's designed to do something pretty remarkable. Unify what a robot sees, the language it understands, and the actions it takes into a single cohesive intelligence. Okay, so this is what's so cool about it, how it solves that classic trade-off. See, the old way, you got a robot that was either smart but clumsy, or it was agile but, well, kind of dumb. This new model, it aims for both. It's got a thoughtful brain working in perfect harmony with an athletic body. And the result? Fluid, continuous motion. So the big question is, how on earth did they do it? Well, the secret is an architecture that brilliantly separates the task of thinking from the task of moving. Let's break down exactly how that works. It's called a mixture of transformers. The best way to think about it is like a team with two specialists. You've got the strategist, the one who understands the big picture, the what and the why. And then you have the athlete, who just executes the plan flawlessly. They work together, but they each have their own very specific job. Now, check out this analogy, because it's perfect. The Vision Language Model, or VLM, that's the brains. It's like a chef reading a recipe and planning out the whole meal. Then you have the Diffusion Transformer, or DIT, that's the brawn. Those are the hands that are just chopping the vegetables with fluid, practiced muscle memory. The mind plans while the body executes. It's brilliant. And what this dual system does is it fixes one of the most awkward problems in robotics, that jerky stop-and-go movement we're all used to seeing. By having the brain and the body work asynchronously, which just means at the same time but on different schedules, the robot can move continuously while it's thinking about what to do next. And this quote just perfectly illustrates the difference. Old robots were like trying to walk down the street but having to stop every few feet to check a map. This new approach, it's like streaming a video, where the system is always buffering the next few seconds of motion so the action you're watching never ever stops. And the numbers really back this up. We're talking about an 80 millisecond inference latency. That is incredibly fast. It allows for smooth 30 Hz real-time control that can respond pretty much instantly to the world around it. Okay, so the theory is impressive, right? But does it actually work in the real world? This is where the story gets really, really compelling. Let's look at the data. So let's just start with the headline number. On the Libero benchmark, which is a standard set of tests for complex robotics tasks, this model achieved a staggering 98.7% average success rate. That's not just good, that is incredibly reliable. And this wasn't a fluke, not at all. Across a whole bunch of standard tests, it consistently came out on top. On the Kelvin benchmark, it outperformed around 30 other solutions. And in a really complex Lego disassembly task, it was a full 25% faster than its competitors. This thing is a serious performer. And to really appreciate what this all means, just think about a task that seems so simple to us, like folding a towel. For a robot, this is a multi-step nightmare. It has to find it, grasp it just right, spread it out, fold it with the right tension, and then stack it. I mean, every single step requires different levels of force and precision and visual feedback, and this model, it just nails it. But here's the part that might be the most significant of all. Really, it's not just what the robot can do, but where it can do it. This whole state-of-the-art system, it doesn't require some government-funded supercomputer. It runs on an NVIDIA RTX 4090. That's a high-end, sure, but a commercially available consumer graphics card. That, right there, is a game changer. And here's the really crucial point.
When you lower the barrier to entry like that, you invite the whole world to come in and innovate. You don't have to be a massive corporation anymore. Now, a university student, a small startup, or even just a hobbyist in their garage can work with cutting-edge AI. And Xiaomi didn't stop there. They doubled down on this whole idea of democratization. They didn't just publish a paper about what they did, they gave the entire thing away.
I mean, they released everything. The model architecture, the training code, the pre-trained model weights on Hugging Face, the fine-tuning guides. It is all on GitHub for anyone to download, use, and build upon. This is how you accelerate progress for an entire field. Now, this isn't the end of the story, of course. The system is incredible, but there are still some pretty significant hurdles to overcome and some really exciting frontiers to explore. For instance, it still struggles with very long-term planning, over many, many steps. It also needs huge amounts of human demonstration data to learn. And like most robots, it can get a little confused by major changes in its environment. Like if the lighting suddenly changes, these are the next big problems to solve.
But the path forward is pretty clear. The next steps are going to be scaling this up to control full humanoid robots, adding new senses like touch and force feedback, and creating systems that can learn continuously from their own experiences. I mean, this is the foundation for a true general-purpose robotic assistant. And that really leaves us with this final thought. For the first time, the core components for building truly intelligent, physically capable machines are not locked away in some private corporate lab. They're available to everyone. So the question is no longer if we will build this future, but what kind of future all of us, together, will choose to create.